Okay, let's talk about statistical significance. So after performing statistical significance tests, there are basically two possible conclusions. We either, well, there is statistical sufficient evidence for alternative hypothesis, and if there is enough statistical evidence for alternative hypothesis, then we say that we reject null hypothesis, HO. Or there is not enough sufficient evidence for the alternative hypothesis, and then we fail to reject HO. So notice that in both cases, our conclusion is always in terms of the null hypothesis. So this is our conclusion, and we either reject the null hypothesis or we fail to reject the null hypothesis. But notice in both cases, it's all about the null hypothesis because the null hypothesis is the one that's, as we say, is on trial. We either accept the original one, sorry, not accept. We either reject the original claim or we fail to reject the original claim. Now, I just had to correct myself when saying accept the null hypothesis because that is a very common AP exam error. One of the most common AP exam errors is the following. Or I guess that's not the error, but what you should never do. We never accept the alternative hypothesis. We either reject the null hypothesis or we fail to reject the null hypothesis. Okay, so once again, the null hypothesis is the one that we are testing. We're not testing the alternative. The alternative is what we have found, but that is not what's on the test. We're testing only the null hypothesis. And we have only two options. We either reject the null hypothesis or we fail to reject the null hypothesis. We never accept the null hypothesis. We never accept the alternative hypothesis. Those are the only two conclusions that we have. Reject the null hypothesis or fail to reject the null hypothesis. Now, how do we determine when we reject the null hypothesis? Well, it's all about the p-value. So the general rule is the following. If p is low, reject, you can fill in the blank there, how you say it. Some people say HO, some people say it differently. Anyways, so now what is the good p-value at which we either reject or fail to reject the null hypothesis? Well, now we're finally going to learn about this whole, 5%. Why is 5% considered to be okay or not okay? So p-value required to reject the null hypothesis is subjective. However, we can compare the p-value to the value that is fixed and decisive, which we call the significance level. So the significance level is basically the cutoff point at which we consider that the p-value is too low. So let's write down this definition. If p-value is smaller, oh yeah, by the way, we're calling this significance level by the Greek letter alpha. So if the p-value is smaller than alpha, and by alpha, once again, we do mean the significance level, we say that the data is statistically significant at level alpha. In that case, we reject the null hypothesis HO and conclude that there is convincing evidence in favor of the alternative hypothesis. So once again, notice we reject the null hypothesis, but we do not accept the alternative. We're saying that there is convincing evidence in favor of the alternative. Now, the level alpha, the significance level, there are three general levels that we usually going to consider, and those levels are 10%, 5% that we've been talking about for a very long time, and 1%. Now, which one has to be chosen? It depends on the situation and on the context. In different fields of studies, different levels are used. These are three that we are using in our AP statistics class as part of the curriculum, but in real world, different levels could be very, very different. For example, if we're talking about an introduction of some kind of a new safety measure that's supposed to improve some kind of a safety in any aspect, we probably would want the significance level to be fairly low, like 1%, because that our null hypothesis will say that the new safety measure does not change um, the safety at all, while the alternative hypothesis will claim that it has improved the safety. So we want to be very, very sure that the new safety measure has actually improved uh, the result. So, but anyways, you can read a little bit more about the significance level on page 537. It's not 47. So it goes into a few details and it talks about where this 10%, 5%, and 1% came from. But it's not as important to us right now. So I'm not going to talk about it, but you can read about this. So let's look at an example where we will decide whether we reject or fail to reject the null hypothesis and why. So this one is not nearly as important as some kind of safety procedures, but still. So for his second semester project in AP statistics, Zenon decided to investigate whether students at his school prefer name brand potato chips or generic potato chips. He randomly selected 50 students and had each student try both types of chips in random order. Overall, 32 of the 50, or in other words, 64% of students preferred the name brand chips. The non-performed the significance test using the hypothesis. So once again, the idea here is the following. We are claiming, the original claim is that there is no difference, meaning that the students don't distinguish between name brand chips and generic brand chips. However, he picked a sample and his sample claimed that there is a difference of because 64% preferred brand name chips. So here's what we're testing. Remember, you're writing your null hypothesis and alternative hypothesis always in terms of the population, or in terms of the parameter. So notice that in both cases, we are using P and we're stating that there's either no difference, so P is equal to 0.5 or 50%, or that population parameter is greater than 50%. So P is greater than 0.5. So notice that in both cases, we're using the same numbers in both alternative and the null hypothesis. So this value right here that was found as the result of this experiment is not really included in the null hypothesis or alternative hypothesis, and it never will be. Never write your null and alternative hypothesis in terms of your uh, statistic, in terms of p hat or x bar when we talk about the means. It's always in terms of the parameter only. Notice that we do need to define the parameter as well. And we're not discussing how the significance test was created because we haven't talked about this, but we are told that after the significance test was done, this person found the p-value to be 0.0239. So now the question is, should he reject or fail to reject the null hypothesis? Well, it depends on what alpha level was chosen originally. Now, normally, we pick the alpha level, we pick our significance level before we perform the experiment. If you pick the significance level after you perform the experiment, that is considered to be unethical because then you are adjusting the conditions to the result that you want to have. Usually this is done in the beginning, so usually we will state the alpha level right here in the state part where we're gonna right? Null and alternative hypothesis. But for our purposes, we are looking at two different situations depending on the alpha. So here, part A, if alpha is 0.05, or in other words, 5% significance level, well, then our p-value, which is 0.023, well, it is clearly less than alpha. And if p is low, we reject HO. Therefore, there is enough statistical evidence that students prefer brand named chips. Okay. Then we have, what if our p-value is different? What if, sorry, not p-value, what if our alpha level was different? What if it was 1%? Well, then the p-value is clearly greater than 1%. And then we fail to reject. We fail to reject HO. Therefore, there is no convincing evidence that students prefer brand name chips. Okay, so in conclusion, remember p-value is the probability of getting the result that you've gotten from your sample by chance alone, and you compare it to the significance level alpha. And if your p-value is less than alpha, then we reject the null hypothesis. And if the p-value is greater or equal than alpha, then we fail to reject the null hypothesis. Okay, so that would be.
Good morning, Cougars. It's Mr. Hudson.
Well, this will teach me to record videos in the morning right before the first period starts. Anyways, this is the end of our lesson. We will continue talking about significance level and the null and alternative hypothesis, and what happens when you make a mistake, when you accidentally reject the null hypothesis when you should not have, and when you fail to reject it when you should have. And we'll talk about that in the day 2 of section 9.1. Up until then, have a wonderful day.